All right, let's dive right into today's explainer. We're looking at the true cost of decarbonization and uncovering a massive $2.2 trillion energy bubble. We are going to investigate the real numbers behind the global energy transition and, in the process, uncover a hidden financial mystery that's literally hiding in plain sight. There's so much excitement right now about all the shiny new renewable energy resources coming online, and I think we all feel a bit of optimism looking forward to a sustainable future. But when we actually dig into the data, the projections, and the actual flow of global capital, a completely different and frankly shocking story emerges. You've probably heard the claim that abandoning fossil fuels too quickly is going to bankrupt nations. The naysayers often argue that if we rush headlong into a completely renewable grid, civilization will break down, economies will collapse, and will essentially be sent back to the Dark Ages. But we really need to look at the data to see if that's actually true. Is it truly a huge economically existential risk to rapidly decarbonize? Or are the people telling us to slow down missing something fundamental about how technology and markets actually work in the real world?
Well, to figure that out, we first have to look at the tools our global policymakers actually rely on. They use what are called integrated assessment models, or IAMs. Think of these models like a massive data soup. Policymakers throw in all these real-world variables, economic processes, greenhouse gas emissions, governance, health, education, mix them all together and pull out future projections. The problem is, sometimes the recipe is just completely wrong. These models, which are included in massive reports by organizations like the Intergovernmental Panel on Climate Change, consistently tell our leaders that renewable technology costs are going to start out very high and only fall very, very slowly over several decades.
But here's the thing. Researchers have found a massive blind spot in those slow-moving models. A team led by Michael Grubb at University College London analyzed 228 previous real-world studies going back half a century. And what they discovered is that while mainstream models are really good at calculating technological push, things like government R&D funding that slowly brings a product to life, they entirely miss market pull. Market pull forces, like carbon pricing or simple cost incentives, create massive self-reinforcing feedback loops. As deployment goes up, costs decline, which then drives exponential expansion. The models assume a slow crawl, completely ignoring the historical reality that market forces actually cause renewable costs to rapidly and exponentially collapse.
And this isn't just an academic debate. This blind spot bleeds directly into our current policy landscape. Take a look at projections from the International Energy Agency, the IEA. We see two main scenarios for our future emissions up to the year 2050. There's the optimistic view, which is based on announced pledges, and the pessimistic view, based solely on the laws that exist today. But here is the really terrifying part. Even under the optimistic scenario, the IEA suggests fossil fuels will still make up about 20% of global electricity generation in 2050. Both of these scenarios show a huge deficit between the emissions drop we absolutely need to hit net zero and the drop we're actually going to get.
So how on earth do these major global agencies plan to bridge that massive gap? Basically, they're gambling on carbon capture. Almost all of them assume we'll just be able to suck tens of billions of tons of CO2 out of the atmosphere every single year and store it safely forever. But gambling our entire future on this is an enormous risk. We're talking about scaling completely unproven technologies by a factor of thousands in a wildly short time frame. Plus, there's a severe economic temptation for commercial companies to just take that captured carbon and convert it back into hydrocarbons to burn as fuel all over again. And even if we pump it under the North Sea, we face unpredictable storage risks. Things like ocean acidification, underground leakage, or the gas simply releasing right back into the atmosphere.
Okay, so that brings us to the financial mechanics underneath all of this, and this is where things get truly fascinating. The industry standard tool for comparing energy costs is called the levelized cost of electricity, or LCOE. Put simply, it calculates the lifetime costs of the energy generated from power plants. It's essentially the ultimate price tag. Mainstream organizations use LCOE to tell us whether coal, gas, nuclear, or renewables are the better financial bet. But an energy consultancy called RethinkX, founded by Tony Seba, analyzed exactly how these mainstream agencies calculate LCOE. And what they found is a financial secret that completely turns the entire energy market on its head. The fatal flaw they found in mainstream models comes down to their assumption about something called capacity factor. Basically, the models assume conventional power plants will be able to sell the exact same quantity of electricity every single year for the next few decades. But in the real world, as near-zero marginal cost solar, wind, and battery storage exponentially grow, conventional plants are just getting squeezed out. Real-world data from the UK shows us exactly what this looks like.
The capacity factor, meaning how often these plants are actually turned on and running, collapsed from 58% in 2013 to just 8% in 2019. Conventional plants are quite simply sitting idle while cheap renewables eat up their market share.
And that brilliantly illustrates the central flaw of our global energy markets. The mainstream models, like those from the U.S. Energy Information Administration, are out there telling investors that new conventional power plants commissioned all the way out to 2035 will magically maintain a highly profitable 85% capacity factor. That false math makes their electricity look cheap, around 7.5 cents per kilowatt hour. But the reality, based on the exponential market pull of renewables we discussed earlier, shows actual capacity will be driven down to just 10%. When a multi-billion-dollar power plant is only running 10% of the time, the true cost of its electricity becomes more than 10 times higher than those official estimates.
Because these mainstream LCOE figures are so highly sensitive to those capacity assumptions, conventional energy assets have been made to look far, far more financially attractive than they actually are. The result of that? $2.2 trillion. That's the staggering amount of investment that has mistakenly poured into the global fossil and nuclear power sector since 2010 alone, and it was all based on flawed math.
This dynamic brings us to a quote from Tony Seba that summarizes the situation perfectly. He says, investment in an asset class above and beyond what the fundamental value can return, based on shared and widespread false assumptions, is the very definition of a financial bubble. Rethink X argues that because global policymakers totally failed to account for the exponential disruption of renewables, they've unwittingly inflated a massive, rapidly expanding financial bubble, and it's currently hiding right under our noses.
So here is how this timeline actually plays out and why it matters directly to you. In the present day, zero marginal cost renewables are already disrupting the markets. By the late 2020s, the utilization of conventional coal, gas, nuclear, and hydro plants will be driven towards zero. And by the year 2030, the majority of these legacy assets become completely financially unviable. We are talking about stranded assets. And remember, the investors holding the bag on this aren't just wealthy venture capitalists who can afford to lose a few billion. The people holding these assets are institutional pension funds. That means it's the retirement savings of everyday, ordinary people that are tied up in power plants, pipelines, and ports that will very soon be entirely obsolete. As we wrap up this explainer, we have to look to the future. The data shows us the transition is happening exponentially, driven by unstoppable market forces, regardless of what conservative, outdated models might project. But if our governments fail to grasp this reality, they won't put strong policies in place to manage the orderly decline of these legacy power sources. So I want to leave you with this question. If policymakers continue to stumble blindly into this market disruption, what actually happens to the stability of our global electricity grids and the security of our life savings when this $2.2 trillion bubble finally bursts?